Let's sketch a derivative. If you're like me, I hate these problems because I want my final answer. I can put a box around the end. I don't like these sketch, approximate, estimate. I hate it, but we can do it. First thing I'll do, give myself an xy axis here. So given y below, sketch dy dx. I'm going to look for some distinguishing features. And the first thing I always look for is where is the graph flat? Where is the derivative equal to 0? And I see that's going to happen right here, here, and here. So those are points that I know right away that thing's going to be equal to 0. So remember, you're matching the x-coordinates. So wherever the x-coordinates are here, it's the same x-coordinates here. And then the slope becomes the y value. So since my slope was 0, that's my y value. Slope was 0, that's my y value. Can I undo some of those arrows here? Got a little over, there we go, that'll work. So then I look at each region in between those zeros. So I'm going to look at this region first. And first thing I ask myself is this thing positive or negative? The slopes here are all negative. That tells me I'm going to be below the x-axis. So a negative slope means I'm below the x-axis on the derivative. And I see that it starts steep and has to approach 0. So it starts at a high number and has to approach 0, like that. Now let's look at what happens between here and here. The slope is positive, and it starts at 0, and it's got to come back to 0. So it's positive, it's above the x-axis, it starts at 0, and it's got to come back to 0. Now, I don't know if it should do this or this. I have no way of knowing that. This is an approximation. It says to sketch the graph. So it's okay that I don't know exactly how steep to make that thing. Let's look at the next region from here to here. The slope is negative, and again, it's got to start at 0 and come back to 0. But it's all negative, so it's below the x-axis and comes back to 0. And then for this region right here, it's all positive, so I know I'm above the x-axis, and it starts at 0 and gets steeper, starts at 0, gets steeper. I'm going to call that my derivative. Now, if I have some intuition about this, I made a real mess out of this graph over here, but it started out looking like that. If you have some intuition, I know that that's a, what do you even call that? Quartic? It's a quartic graph. So if I take the derivative of that, 4x cubed, my derivative should look cubic. And I feel pretty good about our graph that we've got here. That looks cubic to me. Let's do some other types of problems. Let's say we're given this graph. This is a piecewise function. Let's pretend it's defined here and undefined there. I don't think it'll matter. We can answer all kinds of problems from graphs like this. Let's start with this problem. Estimate the derivative of x equals negative 4. And you say, but wait, I don't have an equation. How am I supposed to find the derivative? This question's asking, do you know what a derivative is? And the derivative is the slope. So I go to the x value of negative 4, and I want to estimate that slope right there. Now this is a straight line, so I can choose really any points that I want on that line to figure out the slope. I'm just going to do classic rise over run. If I had any variation, I would want to choose points as close as I could around that point. Remember, this would be the instantaneous rate of change at one particular point. We're going to have to estimate it with an average rate of change over some points. But let's get as close as we can. Let me get rid of some of those marks. So let's see, if I want that point, I could choose that one and that one. Just because they're on coordinate lines, I can tell exactly what those points are. This one would be negative 2, 0. And this one would be, what is that, negative 6, negative 4. And then I can do good old classic rise over run. So that's the change in y over the change in x. And remember, it doesn't matter what order you go in. You could have done negative 4 minus 0 over negative 6 minus negative 2. Just do the same order for the x and the y. Whichever one you choose, stick with it. So I'm just going to go open my blank space here. So 0 minus negative 4 is positive 4. Negative 2 plus 6 is positive 4. So that derivative is 1. And it's a straight line, so I know for sure that that is the derivative. If we're somewhere here on a curved line, it would be more of an estimate. That's okay. All that's okay. Let's see if I can just clear the ink here. There we go. Fresh start. Let's do another one. Let's find f prime of 2. F prime of 2. 2 is right here. We've got a problem, right? Things are only differentiable if the function is continuous and smooth. This is not continuous, right? We have a left-hand limit, but it does not match my right-hand limit. So it fails our textbook definition of continuity. It fails our old-fashioned definition of continuity. I can't draw it without picking up the pencil, right, to get from here to here. So if it tells you to find that derivative, it's a trick question. You would say that f of x is not differentiable at x equals 2. If you're in a hurry, in a can't find the derivative at that point. So let's try a different one. Let's find the derivative at negative 2. If I go look at negative 2, I still have the same problem. This is not differentiable. It's continuous. I can draw without picking up my pencil. It's continuous, it's defined, but it's not smooth, right? If it comes to a sharp point, that is considered, I think it's called a cusp. And so that is not smooth. It's a sharp point. And so once again, we say that this thing is not differentiable. Let's do another one. Let's find the average rate of change on the interval, let's say 0 to 2. So this is just some vocabulary, right? When we find a derivative, we're finding the exact instantaneous rate of change at one particular x value. When we find the average rate of change, we're finding the average of all the slopes between x equals 0 and x equals 2. We calculate it the same way from a graph. We're going to calculate the exact same way. This is giving you your x coordinates. So I'm at x equals 0 and x equals 2. And I'm going to find the average rate of change. I'm going to find the slope of the line, pretending that it's not curved. Right? I'm just going to find that slope between those 2 points. And so that's your classic rise over run. Change in y over change in x. So let me write down my coordinates here. This was 2, 0, and this was, nope, 0, negative 4. So my change in y over my change in x. And again, it's okay if you flip those, just make sure you flip both of them. So I have negative 4 over negative 2, and so that is 2. Done. And you could do all these same things. You could answer all these same questions with a table. Now, a table is not going to trick you with any discontinuities like this. Just assume that the function is continuous, or in fact, the question would probably tell you that it is continuous.